The 1915 Nobel Prize in Physics was awarded to not one but two men. The man on the left you'll see is Sir William Henry Bragg, who was a physicist, had backgrounds in chemistry and math. He was an active sportsman. He actually was also knighted in 1920. But we're not talking about 1920 yet, we're talking about 1915. He was a great teacher, he was a mentor, he was also a father, and if you look to the right, you will see his son, Lawrence Bragg, William Lawrence Bragg, who he shared the Nobel Prize with his dad. William Lawrence Bragg, the younger of the two, actually holds the record to this day for being the youngest Nobel laureate ever. He was merely 25 years of age when he won the prize. That makes them the first, and to this point, only father and son team to win. Now, one of my favorite shows growing up was a show called Connections with James Burke, who's actually still with us, and he's still doing a very similar show on one of the channels that are out there. But one of the things he loved to do in that show was show you how different inventions were connected, and how different techniques were connected, and different sciences were connected, and how something that happened 200 years ago influences the way we live today, because the world of science and engineering is really very heavily connected. Now, remember, it was just the Nobel Prize the year prior that showed that X-rays were in fact traveling as a wave, not as a particle. That's a very important thing to understand, because if it travels as a wave, that means we can use them to do things, because we have a lot of stuff built up in the scientific community at this point to measure waves and to understand them. But X-rays, because their wavelength is so short, you've got to use something that's very precise. So these two work together to build the Bragg X-ray spectrometer, which you see in front of you. But what that does is it allows you to introduce X-rays to a sample and measure what bounces off at different angles. That the angle that something bounces off at will tell you a lot about the elemental composition of that specimen. So is that specimen 100% sodium crystal? Is that specimen partially gold? Is it partially silver? It will tell you to some great degree of accuracy what that material is made out of, down to the atom level. And think about that. This is the early 1900s. They're telling you down to the atomic level what's in that particular sample. This technique, while it may not have been as accurate as it is today, is still used in laboratories today. It is still seen with techniques like Pixie. It's used in X-ray fluorescence, or XRF. It's used with all kinds of things in laboratories all over the place, not just at the undergraduate level, but at the graduate level. You will see publications on how to even improve these techniques still today in 2024. So this was not a group of guys who were just saying, oh, let's just kind of put something together that works for now. They developed a groundbreaking technique that is still being used in a much more advanced way more than 100 years later. Now, you might be saying, hey, Dr. Imholt, all that's great in the lab, but what does that really have to do with my life? Well, admittedly, not much. But now, Bragg, the younger of the two, early in World War I, was drafted into military service. He was commissioned into the Royal Horse Artillery as a second lieutenant. And he was assigned to a Royal Engineering group and was told to develop a method to localize enemy artillery fire if at all possible. So in September, after his brother was killed during a campaign, he came up with a technique to figure that out. And what he did was he was using sound ranging and the differences in the sound across different microphone setups to localize and triangulate in on enemy artillery positions. Now think about that. This is still the early 1900s. This is not, go down and order a bunch of stuff on Amazon to figure this out. This was all still very early technology. And when he put this together, then they were able to use information coming off of those microphones to figure out exactly where enemy artillery positions were. Now, it wasn't real time. We don't have computers. We don't have ways to, email data around. It did take a little time to figure that stuff out. But it meant that the Germans had to go off and move their artillery around, which is not the easiest thing in the world to do. So he worked on that project during World War I. It was fielded. It functioned. He actually wound up doing even more of that work during World War II as a civilian advisor. So while a lot of their work that they won the Nobel Prize for is truly great in labs and still used more than 100 years later, he was not someone who just sat back and goes, okay, great, I'm finished. Nope, he actually served his country in a much greater sense and figured out how to use what he did in the lab to serve a much different need in the early 1900s.